Consider another example, the K-truss. It is so called because the vertical members starting from O2 and the two inclined members starting from O1 form the English letter K, and therefore it is called the K-truss. For the reactions, we have YA and YB. Of course, we have an XB here, but it is 0 because we have no horizontal forces. From symmetry, YA equal YB, and we have 1, 2, 3, 4, 5, 4 tons. Each support carries half the load. So we have 4 tons multiplied by 5 repetitions over 2. Each support has a reaction of 10 tons. Now we consider O1. We consider the inclined members to compute the angle theta. So each member here is inclined to the horizontal by the same angle theta. This is because O1 is really in the middle of this vertical member, and the dimensions here are 1.5 meters and 1.5 meters. The horizontal panels are 4 panels, each of 3 meters. And therefore, tan theta equals 1.5 meters divided by the horizontal panel 3 meters equals 0.5. This gives a cosine and a sine of the shown values. We start computing internal forces. So we have joint O1 here. We consider all internal forces in the members to be tension forces, and we extract O1 outside. Please note that O1 has 4 members connected to it: the vertical O1, O2, and the lower vertical, and the 2 inclined members 1 and 2, member 1 and member 2 shown in brown. We extracted outside here, and we are considered with F1 and F2 to start computing them. Those are the 2 inclined members that form the K shape. Here is the K shape. Each force is analyzed into a horizontal component and a vertical component. We are interested in the horizontal components, so we have sigma forces in the x direction equals 0. We sum up the horizontal components to be 0. This equation has 2 unknowns and therefore needs another equation to solve 2 equations in 2 unknowns. For now, crossing out the cosine theta, or in other words, dividing the whole equation by cosine theta, we have F1 equals minus F2. Our truss is here, and we have a section S1 to have the other equation to compute F1 and F2. We extract the left part of the section as we previously explained in previous examples. And we have the analysis of F1 and the analysis of F2 in the horizontal and the vertical directions. We are interested in the vertical direction now to get the second equation in F1 and F2. So sigma Fy equals 0. We consider the external forces, 10 tons, 4 tons, and the other 4 tons, the forces in green and blue, and we consider the vertical internal forces F1 sine theta and F2 sine theta, respecting the signs. Now we will substitute for F1 from the previous equation. F1 equals minus F2, and we have another minus in the original equation. This gives an equation in one unknown F2, and F2 equals minus 2.24 tons. Considering the first equation gives that F1 equals 2.24 tons but tension. To sum it up, to compute the two inclined members forming the K shape in a K-truss, we consider two equations. One of them, sigma forces in a certain direction at the joint. The other equation, sigma forces in the perpendicular direction for a section. This is not standard, of course. You can have any other method, but this was the method adopted here. To proceed with internal forces, we proceed with our internal forces by this section S1, S1. We consider the left part of the section, and we recall that the internal forces that appear are the internal forces of the cut members only. We extract the part of the truss here, and we have the analysis of F1 and the analysis of F2 in the horizontal and vertical directions. Now sigma moments about O2 equals 0. Now the cut S1 cuts four members, F3, F1, F2, and the horizontal member passing by O2. Considering moments about O2, this horizontal member will not appear in the equation. F1 and F2 are previously computed, so we are left with the only unknown F3. Substituting for F1 and F2 from the previously computed results, we get that F3 equals 6 tons. This is the third member in the truss to be computed. Now we have our truss again. We consider this snaky section. Consider it section S2 here. And we extract the left part of the section. Please note that section S2 cuts four members. The horizontal member on the upper chord, the horizontal member on the lower chord, and the two vertical members passing by O1. And therefore, those four internal forces appear. We extract the left part of the section outside for our computations. We have sigma moments about O2 equal 0. This cancels three internal forces, the horizontal force and the vertical force passing by O2, the vertical force here passing by O1 because it really passes by O2 also. And we are left with the only force F3. This is another method or another cut for computing F3, and it should lead to the same result, 6 tons. So we have our equation here, 10 by the arm 3 minus 4 by the arm 3 minus F3 by the arm 3, which gives F3 is 6 tons. In this example, we will not compute all members as it will be repeated. Ideas. So let's consider members 5 and 6. They really resemble members 1 and 2 and could be easily computed by two equations having two unknowns. So we consider the first equation, joint O4 and sigma forces in the x direction equals 0. We can have a vertical cut for the second equation and consider sigma forces in the y direction equals 0 for the right part of the section passing through 5 and 6. Two unknowns in two equations can be easily computed. Member 7 can be computed from joint O5 and sigma forces in the y direction equals 0. Now we already computed force 5 and we can compute force 7. Member 4 really represents member 3 and can have this snaky section passing by 4 and 7, and considering sigma moments about O3 equals 0, it will give simply the force in member 4. Of course, to compute the force in this vertical member in the center, we must have those two members. If the truss is symmetric, so we have the member we are pointing at here equals member 2. If not, then we will consider the K here and we will consider and compute those two inclined members and take at the upper joint here sigma forces in the y direction equal 0. We have member 2. We considered that we computed the other inclined member and we are left with the vertical member unknown, which could be easily computed. Of course, we can now conclude that some members can never be computed unless we have a series of computed members before it. This concludes with our K-truss.